Here is the last part of the lesson, rational numbers, the part 6. Observe, here are few examples of usage of properties of rational numbers. Among these, few are correct usages, few are not appropriate. So it is very important to identify and know what way we have to use so that it is helping us to solve the sums quickly or in an easier way. So observe the first question. It is having two operations, into and plus both. So it is easy for us to identify that it is demanding distributive property. But if you keenly observe the first product 1, 2, 3, 4 into 99, if we use the distributive property by splitting 99 as 90 and 9 and then finding the products, subproducts 1, 2, 3, 4 into 90 plus 1, 2, 3, 4 into 9 and then finally adding that 1, 2, 3, 4. In the given question, it appeared as apart from the product 1, 2, 3, 4 into 99. So adding that 1, 2, 3, 4 finally and then getting the answer. This is not at all actually appropriate way. Let us know why it is not that correct. Say 99 and 1, 2, 3, 4 when we multiply in the beginning, is it not if I directly multiply 1, 2, 3, 4 with 99, are we not multiplying that by units first and then by 90? That is actually normal multiplication itself. I illustrated in the beginning when I explained distributive property as it is nothing but the normal regular multiplication which we use. But we write the places and then write. So splitting also is 90 and 9. 99 is as per place value way. It is product is like this only. So there is no actually property applied. It is appearing that we have used a distributive property, but it is not helping us to solve the sum faster. Instead, it is normal. So it is answer may be right, but the way approach is not going to simplify the sum. So it is not correct. Moving on to the second, adjacent right side, find using property. Here also, as the question is same, we go for distributive property. And here we need to visualize that product of 1, 2, 3, 4 with 99 when added to itself 1, 2, 3, 4, it is one more time that number getting multiplied. So it is into 1. So that is identified and rightly written. And now it is of the form A into B plus A into C. So here A is taken out. The common term is taken out. A into B plus A into C is A into B plus C. So that's how 99 and 1 become the addends and they stay within the bracket. And finally we add those and then multiply to get 1, 2, 3, 4 into 100. And this can be done mentally. So here any question which is given appearing to be complex has now become simple by using the law. So this is how the law has to be used in the appropriate way. Third one more error, common error. Instead of writing into 1 in the previous approach, how we have written into 1, instead of that into 0 is written, then the answer itself is wrong. And we have neglected that 1, 2, 3, 4 totally and just multiplied that 1, 2, 3, 4 with 99. This is also wrong usage. Consider two examples for simplification using the properties of numbers. Both of them are finding the products. So here choosing the appropriate property is very important. First one, it is multiplication of 78965 with 99. And in this case, as only two numbers are given that they are getting multiplied, there is no question of grouping as such. Also, the most comfortable and faster approach to this sum would be to multiply by 100 minus 1, that is splitting 99 as 100 minus 1. In other words, multiply 78965 to 100 first and deduct itself 78965 from the resulting product. So that is application of brackets or the property of distributivity of multiplication over subtraction. Next one, three numbers are getting multiplied. So among these, if two are paired, especially when we see 125 and 8, if you pair those two, the result is 1000, and that when multiplied to 78965, the answer obtained is 78965,000. So here we are using associative property as we are grouping the two numbers as per the convenience. So observe the difference between the two. One is distributive property, another is associative property, but the case both are multiplications. So you need to be very clear where which one has to be used. For this you need several such sums in hand to observe and try it out. Observe, for rational numbers we studied through several examples the property of distributivity of multiplication over addition. Observe here in the left side, first what is given is usage of the law. So you can see pair of rational numbers multiplied and then the results getting added. So among these two pairs, observe which is common. In the first pair 7 by 15 comes, it comes in the second pair also. So observe which is common. So that's why it is written as a highlighted number, that is 7 by 15, and take care of the sign as already taught to you. So when you write 7 by 15 outside the bracket, that is as a common factor, inside what has to come, which sign has to come, that has to be noted and accordingly you write, and that makes the problem easy to solve. First one. Next you see that the direct method. When we directly multiply the first two rational numbers and get its product, and next to get the product, then add. See the LCM how it is growing in size, it is becoming bigger. Observe here the LCM is not that big and there is no actually LCM bigger than 24 in the first, in the easier approach. But in the second direct approach it has come to size 360. So you can evidently see the first one is easy, provided we are very much aware of the common term and how to relevantly write the parts within the bracket. Answer is same. Observe, write and learn. Observe. The bar model method, Singaporean bar model method was introduced to solve word problems, especially where fractional idea is applied. Consider the first sum. Shyam has twice the amount as Manu. Naveen has rupees 46 more than Manu. If all three have a total of rupees 210, find the amount each has. So to interpret this rightly using rectangular bars, use equal units for the fractions because fractions are always in equal units. So write the ratio or fraction in equal represented rectangular bars. Sham has twice the amount as Manu. So observe the first box, rectangular box, is double when compared to the later, that is corresponding to Manu. And if you see the third one, Naveen, he has rupees 46 more than Manu. So just observe, compared to the second Manu's rectangular bar, Naveen's is extending by rupees 46. Now, observe this properly, and as these parts are among the picture, rectangular bars in the picture, 4 are equal sized boxes, but 46 is not known, maybe smaller or more. So we have to consider 4 as 4 boxes, equivalents, and then add 46 so that the sum total is 210. So appropriately apply the equation, transpose the entities in LHS and RHS to find what is one box. So you get it as 41. So when one box is obtained, the whole problem is now solved. The puzzle is solved and the secret is revealed now. Each once you will get it. Sham's amount you got it as rupees 41 into 2 and Manu's is rupees 41 itself, one box value, and Naveen's is 46 more than that one box, 41. So obviously you get it easy. So the approach makes us understand the concepts. So visualizing like this has to be done. Next one, Kumar reads 10 pages of a book on Monday, one third of the remaining pages on Tuesday. If he has 24 pages left to complete the book, find the total number of pages in the book. So I am using the rectangular bars to represent the my interpretation of the problem. So it is told that Kumar reads 10 pages of a book on Monday. So I have written Monday 10 there and one third of the remaining pages. So remaining there are 3 boxes. Among these 3 boxes, one he is reading on Tuesday. And if he has 24 pages left to complete the book, so it means that 2 more boxes are 24. Among the 3 boxes, one is read on Tuesday and 2 remaining are 24. It is obvious that one box is 12. So or 3 is obviously 12 into 3. So you can find the total by adding 10 to 3 equal bars. So 3 equal boxes you get it as 24 and one box is, sorry, 2 equal boxes 24 and one box is 12. So the total is 3 into 12 plus 10. So that is how the whole statement problem is brought down to a pictorial representation which makes us easy to solve. One more similar one is given. It appears slightly complex, but when the picture is drawn and if you try to interpret this, the whole problem becomes very simple. Otherwise, these kind of sums are normally appearing in linear equation lesson where we apply algebra to use algebra for statement sums. But this is easier approach. Go through that and try to understand and interpret. That improves your conceptualization skill in understanding word problems. Another word problem. This is based on area of the circle and area of the square. So there is a square having side 12 units, 12 centimeter, and there are 25 rings within the square, and 25 similar rings, each of radius 4 by 3 centimeter. So R is given in the rational number form. So you have to find the area of one ring by using pi r square formula, and 25 rings by multiplying that area by 25, and area of the square is 144, 12 square. So now finding the unoccupied area by deducting the area of 25 rings from area of the square. It is easy, but you have to take care while calculating because it involves larger numbers. Here is a puzzle, crossword puzzle based on certain terms related to rational numbers. So complete it. Very interesting.